In every massive solar project, there's a real unsung hero watching over the whole electrical system. That's the operations and maintenance technician. Their whole world is the switchgear, which is really the most critical hub of the entire project. So today, we're going to dive into the Guardian's Guide for keeping that hub running, making sure we have uptime, and, even more importantly, safety.
So let's just set the stakes here for a second. What is the one thing, the one critical system that stops a small local fault from turning into a huge grid-level blackout? Well, the answer is the switchgear, and it's all kept in check by a vigilant technician working inside the switchyard.
Okay, so let's get right into it by really understanding this command center. The switchgear is basically the nerve center of the entire solar plant's connection to the grid. It's the place where all that clean energy gets controlled, protected, and sent out where it needs to go.
So at its heart, what does switchgear actually do? Well, think of it as the ultimate bouncer and traffic cop all rolled into one. It's a bunch of devices designed to do three main things: protect all the expensive equipment from damaging faults, control the flow of all that power, and of course, safely isolate parts of the system so you can work on them. Honestly, without it, you'd have no way to handle dangerous faults, and the whole system would be totally unpredictable and incredibly unsafe. So what's actually inside this command center? This is where it gets interesting. You've got bus bars, which are kind of like the electrical superhighways that move power all around. You've got your fuses and circuit breakers. Those are the system's emergency brakes, stopping dangerous faults in their tracks. And then you have the brains of the operation, the protection relays. They're the ones that actually detect a problem, and they get their information from the current and voltage transformers, the CTs and VTs, which are like their eyes and ears, constantly keeping an eye on the system's health.
So, knowing what all the parts are is one thing, but keeping them all running, that's a whole different ballgame. And this brings us right to the heart of the technician's job, the Guardian's Vigil. This is all about being proactive, having a disciplined maintenance routine to stop failures before they can even think about happening. The whole philosophy here is simple. We don't just sit around and wait for things to break. See, the goal of a really great O&M program isn't just being good at fixing problems, it's about preventing them from ever starting. That regular, scheduled maintenance is what makes sure the solar farm is a reliable power horse for its entire life.
And this schedule here, this is the playbook. It shows you the rhythm of that proactive mindset. It's not just a random list of checks. It's a carefully planned dance. Just look at the frequencies. Some checks, like the earthing system, happen every 6 months because, well, a solid ground is just fundamental to safety. Others, like testing the relays, happen less often but are super detailed when they do. This schedule is really the heartbeat of a healthy switchyard.
Now, it's not all about the fancy electrical tests. A huge part of that daily vigil is just using your eyes. These visual checks are simple, but they are so critical. Are you seeing any signs of moisture or rust? Are the cable trenches dry? Are weeds starting to take over? I know, they seem like small things, but every single one is a potential point of failure. I mean, an unlocked cabinet or a little bit of corrosion could be the start of a massive headache down the line. Okay, so let's go from those big picture visual checks and zoom in on something really specific, like testing a circuit breaker. Now, it sounds complex, but it's really just a 3-part health check. First, you test its reflexes. Does it open and close fast enough? Second, you test its integrity. Is the insulation still holding up? And third, you check its internal connection. Is the contact resistance nice and low so power can flow without it dangerously overheating?
But look, even with the absolute best maintenance plan in the world, things can still go wrong. And when they do, the Guardian's role has to shift from proactive prevention to calm, methodical crisis response. We're talking about troubleshooting.
And these are the big ones. The issues that can really keep a technician up at night. A breaker that just won't work, insulation that's breaking down, a relay that trips for no reason, or even worse, one that doesn't trip when it's supposed to. Just knowing what to look for is the very first step in solving the puzzle.
And this slide right here, this is basically your first response cheat sheet. It connects a common problem to its most likely causes and, most importantly, tells you your immediate first steps. So, for example, if a transformer is overheating, you don't just run around in a panic. You start with the obvious stuff. Is it overloaded? Are the cooling fans actually working? And this is critical, because overheating doesn't just waste energy, it actually destroys the transformer's internal insulation, which leads to permanent damage and eventually, total failure. This kind of structured approach turns a crisis into a problem you can actually manage.
But before you lay a finger on a single piece of equipment, you have to remember the golden rule. Listen to the system.
those protection relays, they record exactly what they saw and why they took action. These event logs are like your digital eyewitness. They tell you the whole story of what went wrong, which guides your diagnosis and can save you hours of pure guesswork.
All right, we've talked a lot about protecting the equipment. Now let's get to the most important part of all, protecting yourself and your team. This isn't just some rule, it's an absolute lifeline. We're talking about lockout/tagout. This is the fundamental promise of lockout/tagout, or LOTO as you'll hear it called. It's a super strict set of procedures designed to prevent the single biggest threat during maintenance, the unexpected startup of a machine or the release of hazardous energy. It's all about making sure that when a system is off, it stays off. No surprises.
Now listen, these 7 steps are completely non-negotiable. It always starts with telling everybody what's happening and then doing a controlled shutdown. Then, you isolate the equipment from every single energy source. You lock it and tag it, and then you get rid of any stored-up energy. Finally, and this is the most critical part, you verify it. First by trying to start the machine to make sure it won't, and then by using a voltmeter to prove beyond a shadow of doubt that you're in a zero-energy state.
I really want to pause on step 5 for just a second, because it's a big one. The source material actually calls this one of the fatal 5 causes of injuries during LOTO. Just because you flipped a switch doesn't mean the danger is gone. Capacitors can still hold a charge, pressure can still be in a line. Failing to get rid of that stored energy can be just as deadly as touching a live wire.
So, all of this really boils down to a personal safety checklist. You've got to have the right personal protective equipment, or PPE. You have to be absolutely strict about following LOTO. Always double-check your grounding. And always use tools that are properly rated for the job. These aren't just suggestions. They're the commitments that every technician has to make sure they and everyone on their team goes home safe at the end of the day. So, I'll leave you with a question to really think about. After going through all of this, the complexity, the risks, the procedures, what is the one check, whether it's a visual inspection, a testing step, or a safety rule, that you will absolutely double down on the next time you step into a switchyard? Because at the end of the day, your vigilance is what keeps the lights on, and more importantly, keeps everyone safe.